In this video, we will be talking about dietary reference intakes. Dietary reference intakes are recommendations that are given for different nutrients. This image is taken from your textbook, and as we can see here, dietary reference intakes are sort of an umbrella term. In other words, there are multiple different types of dietary reference intakes, and these are determined by maybe the way that they're measured or the information that's out there. So we're going to take a look at what makes each of these different types of dietary reference intakes different from one another. The first one that we have is estimated average requirements. This is based on scientific data, and what this is saying is that it takes a certain amount of nutrient to meet the needs, the nutrient needs or requirements of a person in 50% of the population. So in other words, what is the value of a given nutrient where half of the people will at least be meeting these nutrient needs? So as we can see here by this bell curve, this side here, 50% of individuals for any given nutrient are going to meet the needs given a specific measurement, maybe it's micrograms, grams, etc. But the other 50% of the population won't be meeting those needs based on that halfway benchmark. So because of this, we can't necessarily use this for recommending nutrients to individuals because obviously this isn't going to be appropriate for 50% of the population. That's where recommended dietary allowances come in. These are based on the EAR, the estimated average requirements that we just looked at. And so what we see here is that we take the EAR and then we place the RDA 2 standard deviations above the EAR. So because of this, by doing this, now we're meeting the needs of 98% of the population. So we can now determine based on this equation what it takes for the majority of the population to meet certain nutrient needs. Now, obviously, there's going to be a small percentage of the population, 2%, that's not covered by this RDA, recommended dietary allowances, but at least we can say that again, majority of the population will be covered, and that's the value that you will see recommended for these nutrients. Now, not all nutrients have an RDA. Some nutrients, there's just not enough information out there in order to determine what this recommended dietary allowance is. And when this is the case, we then determine adequate intakes. So adequate intakes, these are not necessarily based scientifically, but it's more of an assumed value based on observations. For instance, when it comes to newborns or babies, we don't really know what the exact figures are as far as vitamin and other mineral nutrient needs. So because of this, we then set an adequate intake based on breast milk. So what the values of those vitamins, minerals, etc. are in breast milk, because we can say that the majority of babies who are breastfed, they are meeting the appropriate needs. Now, this isn't just for infants. There are some nutrients such as chromium where we're not able to establish an RDA as well. And so again, you'll see this as something called an adequate intake. And then finally, we have the upper intake levels. So obviously, we have now seen that with the RDA, that these are the needs that minimally people need to be achieving in order to maintain good health. Now, that doesn't mean that that's the absolute maximum that they need in order to achieve good health. Just because an RDA set, you can still go over the RDA for most nutrients without suffering ill effects. However, we then establish an upper intake level for nutrients. And what this is saying is this is the maximum amount of a nutrient that you can have before you start to see adverse effects. So for example, for vitamin C, the RDA is set at 65 to 90 milligrams per day. The UL, on the other hand, that's set at 2,000 milligrams per day. So technically speaking, you can have almost 1,000 more milligrams of vitamin C um, than the RDA that is given. Now, this upper intake level for most of us isn't going to be a concern. When we see this more is if people are taking mega doses of let's say a supplement. So if you're taking a large quantity, generally from supplements, then we're more likely to see people exceed these upper intake levels. So for instance, if someone has too much vitamin C, we're going to start seeing individuals experiencing nausea and diarrhea. So those are the umbrella terms as far as our dietary reference intakes. There's a few other additional terms that I wanted to go over that you might experience in this class. The first is percent daily value. This one, if you've already watched the food label video, you'll already be familiar with this one. The percent daily value applies to about ages 4 and upward, and it's based on a 2,000 kilocalorie diet. It's closely related to the RDA, however, not strictly so. And the percent daily value, it helps to determine where people stand as far as how much percentage of a nutrient they need per day. We already talked about this in the nutrition label video, but just to recap, because this is based on a 2,000 kilocalorie diet, this doesn't mean that these daily values are going to be appropriate for everyone. For some of you, a 2,000 kilocalorie diet might not be appropriate. It might be too much, or it might not be enough. So that's something we need to keep in mind when we are referencing these percent daily values. Another is acceptable macronutrient distribution ranges. So essentially what this is saying is when it comes to our energy nutrients, so fat, carbohydrate, protein, polyunsaturated fatty acids, linoleic acid, these need to contribute a certain percent of your total calorie needs. So if we read this, we can say that of your total calories, let's say we're on a 2,000 kilocalorie diet, about 20 to 35% of those calories should come from fat, 45 to 65 from carbohydrate, and so on. Again, you can see there's variation when it comes to these ranges, and that's something that you would need to determine for yourself. It might be a bit of trial and error in order to determine what works best for you and for your personal energy needs. All right, and then finally we have estimated energy requirements. This is the amount of energy or the kilocalories that are appropriate for you personally. These are based on a few different factors such as our biological sex, age, weight, height, and physical activity level. We're going to talk about this more in a later chapter, and we are actually going to be completing the formula for ourselves in order to determine what our personal kilocalorie needs are. So that's something to stay tuned for. All right, lastly, I wanted to go to this nutritional goals index. Let's see, put my screen down a little. There we go. So this is from the website for the 2015-2020 dietary guidelines. And as we can see here, there's different recommendations based on biological sex and based on our age as well. If we look here, we can see the source of the goal, and you can see how these are measured differently. So if we go down to minerals, we see that some minerals, they have an RDA, but for some, we don't have enough information. So potassium, for instance, and manganese, these are AIs instead of RDAs. So this is something that might be of interest for you to be able to see what these different values are. We'll be going over these more further in the class, but just for baseline knowledge, this might be something for you to take a look at. All right, that is all I have for you in this video. Until the next video, take care.